Next topic is the resistors in parallel. Resistors are in parallel if their terminals are connected to the same nodes. The equivalent overall resistance is smaller than the smallest parallel resistor. In our figure, this one, we have resistors R1, R2, and R3. So these are the terminals of your resistor. This one, terminals. Diba? Resistor tayo, Ket. Basta. So these are the terminals. We can say that resistors are in parallel if these two terminals are at the same node. We assumed polarities in our resistors. So this is positive, negative. We can apply this one in parallel. So in series resistors, diba alternate lang positive, negative, positive, negative. But in parallel, it will be positive lahat yung nasa taas, negative lahat yung nasa baba. So how will we apply this one here? This terminal of a resistor, we will denote it as positive, 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 and the lower part of the terminal is negative, negative, negative. Okay? So all of the positive polarities in parallel are connected. All the negative are connected. We can redraw this circuit by combining all of this, like this one. So we have 3 resistors. Combining all of this into what we call node. Or junction. Also, letakin baba. So, patitipunin lang. So, this is node. And it is connected to a battery source. So, these are the various parallel resistor networks. Here, ito yung mga iba't ibang klase na kung saan, kung paano nakakonect yung mga resistors in parallel. Let's say this one, the first figure, A and B, they are connected in parallel. So, paano nakakonect yan ng parallel? We can move this one, B, i-adjust natin papunta dito. Okay? But, if there is a resistor here, example, na the resistor ito'y, you are not allowed to move this one, resistor B here. Saka mo lang ma-move yung resistor B dito pag walang another resistor here. So, this will become stop. Before I forget, this is what we call a node also. When nalipatak na yung baga itay. Ito eh. Or junction. Ito naman, A, B, C, D. So, they are connected in parallel. Ito yung positive, positive, and negative. As you can see, positive polarity of the resistor is connected common in one node. So, this is your node. And the negative here is connected in negative of the resistor A. So, they are connected in a common node. Also here, positive, 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 negative, 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 negative. Connected in a common node. Dito. Also here, dito ba? This one, positive, negative, positive, negative, positive, negative. They are connected in a common node. So that's why you can say it that this A, B, C are connected in parallel. Stamit dito ay nagtitipunin. Positive, negative, positive, negative, positive, and negative. Bali mo at pagtitipunin dito. Basta. This one, just move this one. Dito yung point, i-move mo lang ijay. Tapnon mas ma-imagine mo, i-move mo met data. So, balin nga, kastoy. Kasi pagbalinan na. Ito ni A, ito ni B, and this is your C. Positive, positive, negative, negative. We will now study the relationship of resistance, current, and voltage in a given parallel circuit. Going back to our circuit a while ago, R1, R2, and R3 are connected in parallel. And it is across a 12-volt source between point A and B. R1 has a current of I1, R2 has a current of I2, R3, I3. And this one is the total current, IT. So, IT will pass through I1, I2, and I3. This current, this I1, I1, I2, and I3 will go back again here. So, this one will be your total current. So, ag-loop lang nga masday. So, I1, IT, this one, total current. It will supply currents at R1, R2, and R3. So, resistance. So, resistance. In a given parallel circuit, what will be your total resistance? So, it is the reciprocal. Total resistance is equal to 1 all over 1 over R1 plus 1 all over R2 plus 1 all over R3. And so on. Na dapat R4, R5, R6. If there are two resistors that are the same resistance connected in parallel, let's say R1 and R2 are the same, total resistance of that the same resistances R1 and R2 is just divided by 2. Okay? Either R1 or R2. Kasi the same damit. R1 is equal to R2. Is equal to R2 all over 2. Or, if you have only two resistances that are not the same, two resistances that are not the same, you can use total resistance is equal to 1 all over 1 over R1 plus 1 over R2. If. Or, this is very useful. R1 multiplied by R2 divided by R1 plus R2. Tapnunhan adu nga isursurat yo deti latan. No dua nga resistances. Okay? How about currents in a parallel resistors? It is just the sum of the currents I1, I2, and I3. So, total current is equal to I1 plus I2 plus I3. The voltage across R1 is the same voltage at your source. Okay? So, no mangipan ka iti voltmeter across this terminal R2, you will get or you will read the same voltage as your source voltage. So, the voltage drop across this R1 is equal to your total voltage or source voltage. So, total voltage is equal to V1 equal to V2 is equal to V3. Okay? They are opposite compared to the series circuit. Diba? Ijay series circuit, dito iti equal, dito iti mapag-add. But in parallel, total current is equal to the sum of the currents and the voltage across resistors are the same with the voltage at the source. Don't forget that it is very important to remember the basic principles in series and parallel for you to solve complex circuits. How about the power? So, power, same formula. Total power is equal to total voltage, total current equal to total current squared total resistance equal to total voltage squared divided by total resistance. Same formula also in getting power dissipated in each resistor. So, PA, no alam ti power na jay resistor A or resistor 1, I1 squared R1 or V1 I1. P2 I2 squared R2, diba? Equal to V2 I2. And so on and so forth. here, recall lang natin, we have a series circuit, R1, R2, and R3 connected in series. We can solve our total resistance is equal to R1 plus R2 plus R3. And we have a total current, IT, total voltage. If we simplify this circuit into a simple Ohm's law, we will get this will be our total resistance, diba? Pinagmaymay sa atin detoy. And our total voltage and our total current. Same here in parallel. If we simplify this circuit, we will get total resistance equal to 1 over R1 plus R2 plus 1 over R3. Then, simplifying it into a simple Ohm's law, this will be our total resistance connected to a total voltage. And this will be your total current. Dito yung total current iso di jay at jay. Supplying the combination of these three. Detoy iso di jay RT. Our next topic is the current divider theorem. So, this current divider theorem is applicable only in a parallel or simplified parallel circuit. So, we have here a simple parallel circuit. We have R1 equal to 1 kilo ohm, R2 are 3 kilo ohm, R3 is 2 kilo ohm, and our source voltage is 6 volt. We will try to get this formula no nangalaan na. By the way, this is the formula for current divider theorem. IN, which is the unknown, current unknown, is equal to, so IN, current unknown, multiplied by, is equal to I total multiplied by R total divided by the resistance of the unknown current. So, saan nanggaling tong formula na to? So, we will try to get this one by analyzing our circuit. So, in a parallel, as we discussed earlier, this is the total current flowing in the circuit, IT. And there will be a current agpababa ditoy kasi ti flow ti current is from negative to positive. So, agpakas dyan. Downward ni direction of current. Let's say this is I1 kasi the subscript here is R1. 1. So, I1. Decimet I2 downward. And this one is I3. Again, these 2 points here are what we call nodes or junction. Also this one. Now, the characteristic of a parallel is that its voltage across this resistance, this terminal R1, is the same voltage as our source voltage. Diba? Kung natayo nga ti E, total voltage is equal to the voltage here, E1, the voltage drop at R1 is equal to E2. Same here, numang iban ka ti voltmeter across this resistance, it will read 6 volts. So, E2 is equal to E3. And the current flowing here, I1, from our Ohm's law, I1 is equal to E1 all over R1. Same with I2, E1 divided by R2, and I3 is equal to E3 R3. So let's say adda tayo nga unknown, di ba? It is equal to En all over Rn. Now, In is equal to En divided by Rn. We will make this one as our equation 1. Kantay ti En dito. So, ti voltage drop ijay Rn. We will substitute. Let's say this is equation 2. En is equal to our total voltage, di ba? And our total voltage is equal to total current multiplied by total resistance. So, in-segregate ko lang dito yung equation ni Jai. So, again, this is our equation 2. We will now substitute equation 2 in 1. So, substitute equation 2 in 1. That is 2. So, In is equal to, what is our En? It is equal to IT RT. So, IT RT divided by Rn. So, that is now our formula in current divider theorem. We are now going to solve what is the current flowing here, I1, I2, and I3. Mabalin mo usaran dito yan. Naala mo. But what about when you have a complex circuit? So we will solve I1, I2, I3 using our current divider theorem. So first, we will solve the total resistance. Kasi, isutiyo mo na nga kailangan. So, total resistance for a parallel, it is equal to 1 over 1 all over R1 plus 1 over R2 plus 1 all over R3. Equal to 1 over 1 all over 1K plus 1 all over 3K plus 1 over 2K. RT is equal to 545.45 ohms. So, 545.45 ohms. Now, solving our total current. Saan tayo maalan ni total current? So, total current is equal to total voltage divided by total resistance. We have a 6 volts divided by 545.45. Total current is equal to 0.011 ampere. Applying now the current divider theorem, we will solve I1, I2, and I3. So, I1, dato ni N-mon, so DJ, unknown. It is equal to total current, 0.011 times the total resistance of the resistors in parallel. So, that is 545.45 divided by the resistance of your unknown current. So, ano ti resistance ni I1? We have 1 kilo ohm. Divided by 1K. So, I1 is equal to 6 milliampere. 6 milliampere or 0.006 ampere. So, this is ang hirap magsulat. Next, your I2. Ganun din, I2 is equal to total current times total resistance divided by 45. So, ang value lang, denominator. I2 is, we have 3 kilo ohm. I2, mano deta? 2 milliampere. 0.012 ampere. Or 2 milliampere. Next one, last I3. So, 0.011 times 545.45 divided by 2 kilo ampere. 2 kilo ohm. Sorry, 2 kilo ohm. So, I3 is equal to 3 milliampere. 0.003 ampere or 3 milliampere. So, simple. Simple lang. Recall, voltage divider theorem. It is equal to Vn or your unknown is equal to V total times Rn divided by R total. Diba? But in CDT, In is equal to I total times R total divided by Rn. Opposite. No BDT, numerator ti agpada. Ngem no CDT, denominator met. Ti kapada ni In. Okay, so we will solve. We are now ready to solve complex circuits because we have discussed already the basic. So, kailangan nyo nga maawatan tayo basic. You need to understand the basic principles of series and parallel circuits before solving any complex circuits. Okay?